Hi everyone. Welcome to this webinar on data analysis and visualization using Python. My name is Vinod and I am the head of technology at Great Learning. Before my stint here at Great Learning, I was working in Flipkart as an architect responsible for taking care of the content management system and the seller platform. So in the last few years, I've been, playing around with data. And today I'm here, sharing my experience with you as to how you can use Python to do data analysis and visualization. So let's get started. So before we go any further, let's understand the agenda. What do we want to do? The main thing that we want to do today is, there are two parts to our agenda. The first is to understand the data that we are going to be using and analyzing throughout the next 1 hour. So what I have done is, picked up an open source data set, which is a data set of movies and ratings. So this is a data set of real data where we have movies gathered, over the last 20, 30 years, and we have ratings given by real users to these movies. So those are the two elements of the data. Now this data set is available at the location that I've given here. So what we are going to do with this data is we're going to answer and derive these following stats from it. The first is we're going to look at the movies data, which has a movie catalog. So it looks something like this. So this is how the movies database looks like. So it's a CSV file, which essentially has 3 columns. The first column is the movie identifier. The second column is actually the title of the movie. And the third column is the genres the movie is classified into. So there are many such real movies in this data set. The second part of the data is essentially the rating data, which tells us, what ratings users gave to this movie. So it has 4 columns: the user ID, the movie ID, the rating that the student gave, and the time at which he gave that rating. So basically this movie, for example, the first row says that user 1 gave a rating of 2.5 to the movie 31 at this Unix timestamp. So the movie 31 relates back to this particular row here, right? The Dangerous Minds movie. So this is a brief overview of the data that we're going to be analyzing over the next 1 hour. So now, what are the insights we're going to derive from this data using Python? So first we're going to look at how movies and genres are correlated. Like how many movies are there given each genre. Next we'll try to find out that how many genres do movies have. Do most of the movies have one genre, more than one genre, how many have more than 5 genres, things like that. Next we're going to do something fun. We're going to try and identify masala movies from this data set. And I define a masala movie as a movie which has action, comedy, romance, and thrill in it. So it should be classified into all those genres. And let's see if some interesting movies that we have seen pop up there, right? After that, we'll go into, looking at some statistics into the second data set, which is the ratings data set. So we're going to look at what is the average rating given by users across all that period, what is the median, and what is the percentile ratings that were given by the users. What we are going to also do is, derive and visualize how ratings are distributed. How many movies have got 1-star rating, how many have got 5-star rating, which movies have got 1-star rating, 5-star ratings, and so on. Then we'll move on and try to find the top rated movies across the history of time. What are the top 10 movies that have been rated by users? After that, we will see how ratings, the number of ratings that this data set has got, has varied over the years. So the ratings here have started somewhere near 1996 and they come all the way to 2017. So we'll see each year how many ratings were given by users and see if there is a trend in it. And we'll end our exploration of this data set by creating a machine learning model which will learn based on the number of ratings that have been received in the past and try to predict how many ratings we can expect going forward in the future. So there we'll also try to build a couple of models and see how to compare which machine learning model is a better fit, right? So this is the agenda. This is what we're going to be doing in the next 1 hour. But before we jump into the code and the data, let us also look at, what all can you expect to learn? So obviously we'll do all this analysis in Python, and in Python we'll use the SciPy stack. So that's an awesome, package in Python, which is a stack in Python, which has, packages like Numpy, which is used for all the numeric and, statistical analysis of data. Then we'll also look at the pandas package, which is a great package to represent two-dimensional data in Python and to be able to, play with it, be able to filter it, to be able to select it, anything that you would, think you can do with an Excel, data in an Excel, you can do with pandas in Python. Then for the visualization aspect, we're going to look at matplotlib, which is an amazing library which allows you to create really appealing visuals just using Python. So instead of having a UI interface like Tableau would provide, here you have a programming interface of Python, and you can create charts and graphs, which visualize the data that you have. Then moving on for the machine learning aspect that we have, that we will do, we'll use the scikit learn package, which allows us to build machine learning models, train them, look at their, the accuracy of the models, and so on. So in summary, you'll be exposed to the SciPy stack and to the scikit-learn package. All right, so what we're going to do next is basically jump into some Python code, which is using all these modules to answer all those questions of the data that we have. And that code I have made available on my GitHub repo. That's the GitHub repo where the code that you're going to see is available. It is, you guys can download whenever you want and run it. And to be able to run it, you'll need an IPython notebook, which is an interactive web-based mechanism of running Python code. So you can install that with the link given here. And the data set itself is an open source data gathered by the GroupLens organization, which is available at the link here. Right. So these are the resources that we will be using, and let's now jump into action and look at our data once more before we move on to the code. Right. Just to summarize, the data, once again, the data that we're going to look at is two parts. One is a CSV file of the movies catalog, which is this. It basically has three columns: the movie ID, the title, and the genres. All multiple genres are separated by pipe character, as you can see here. And the second data set that we have is the ratings data, which tells us which user rated which movie, gave what rating, and at what timestamp, right? So these are all real data, these are real movies, real ratings, so we should be able to, come up with some good movies should pop up when we do this analysis. All right, so let's move on to our Python notebook and start analyzing this data. Right, so the first thing is we want to analyze our movies.csv, which is this file. This file. So what we want to do, if you remember first, is we want to be able to play with this data. We want to be able to access this data programmatically in Python. So obviously there are many modules to do that, but the one that I would recommend to play around with tabular data is pandas. So you can just create an object which is a data frame object by reading a CSV file given its path. So what I've done is taken the path of the movies file that I have on my file system, and I've created a movies data frame. So the data frame is the core object in the pandas module, which represents a two-dimensional data structure, much like a relational database table or a Excel file, right? So once we create this movies data frame, we can peek into it using the head method. So let me run this and let's see how it looks. Right. So we just ran this portion of code and this is the output it gave. So basically the data frame object looks like this. It looks very much like our CSV. Now let's go in and explore a little bit about this data. Let's see how many movies are there in this catalog. To do that, what we need to do is measure the length of the index attribute of this data frame. So what a data frame does is for each row it creates an index column. So this is the index column 0, 1, 2, 3, 4 that you see. So if you just measure the length of this column, you will get the size of the data set. So when we run that, we see that there are 9,125 movies in our data set. Cool. So what other high-level information can we extract about this? So there is a shape attribute each data frame has, which will give you the length, the width, and basically the values of the dimensions. How many dimensions does it have? So once we do that, we see that it has 9,125 rows and it has 3 columns. So 3 columns are the movie ID, title, and genre, and there are so many more rows in it. All right. So moving on, given a data frame, how do we access elements at different locations? Let us say we want to access the first movie ID, the first title, and the first genres, right, of the first row. To do that, we use the location method and we pass it, the row index and the column index. So with this, you can access the first row's first element, and the first row's second element, and the first row's third element. So when we run this, we should expect to see one Toy Story and, all the, basically this row. We should be able to see this row. Cool. So now what we have done so far is basically created a pandas data frame, reading the CSV file. We have peeked into it using the head method. We have measured the number of rows in it, using the index, the length of the index, and we have got some idea about how to access elements at different positions. Now let's move on to our first analytics task that we wanted to do. We wanted to find out all the masala movies in this data set. And, I define a masala movie as a movie which has action, romance, comedy, and thriller. And let's see if it pops up some movies that you and me might have seen, right? So what we need to do for that is basically take this data and find out all the rows in which there are all these 4 genres in the genres column. But if you look at this column, it is not structured very well for analysis. First of all, it's a string, it's pipe separated. So we need to somehow, make this actionable so that we can query onto it and filter. To do that, what we would do is create a new column in our data frame called genres array, where we actually populate, the genres as an array by splitting it on the pipe character. So that is what this line of code does. And after that, when we peek into our data, we see that now it has this new column, which is the genres array. So if there are 1, 2, 3, 4, 5 here, there are 5 elements in this array. So now we have taken data, which this will be one of the common tasks you'll do in analytics. You will take data that exists in some format and convert it into another format, which is more queryable for the task at hand, right? So what we have done here is created this new column based on an existing column, which is more actionable. So now to find our masala movies, what we need to do is filter this data frame and create a new data frame with just those movies which have those genres. So for that, what the data frames allow you is to run a lambda function on each of the rows using the map functionality. So I'm defining a masala lambda function, which basically will return true or false based on whether a movie is a masala movie or not. What it essentially does is it checks whether this set is, a subset of the actual genres of the movie. Right, and it will return true or false. And then to run that on our data frame and filter, that is what is done in the second line, the one that's highlighted. So what we're doing here is taking the movies data frame and accessing the genres array in it and invoking the map function on it, passing it the lambda we just defined. And what that will do is give all the rows that match. And to select those rows, we just surround it with the movies data frame. So this way, what we have taken is we have run the lambda function on each of the values of this column, and whatever match, we have selected all those rows. So let's run this and see how many masala movies exist in this data set and what are those. All right, cool. So we have found 6 masala movies, and as you can see, most of them have all of them have the genres that we are looking for. And there is one particular movie that I'd like to highlight here, which is our own favorite Sholay movie. And that's the fun to work with real data. When you work with real data, when you do analysis, you're bound to, find insights that you already know of. So we already know Sholay is an amazing masala movie, and it figures in our list here. And by the way, there are only 6 such movies in this data set which have all those 4 genres. Great. Now, the next task we want to do is basically analyze how many, movies do genres have? How many genres do movies have? Like how many movies have 1 genre versus how many have 2 versus how many have 3. So to do that, what we can do is create another column in our data frame called the genres count, which is basically nothing but the length of the genres array. So if this has 5 elements, we're going to populate a new column which will say the genre count is 5. So let's do that. We are using the same map functionality and populating this new column. Okay, so now we have enriched our data frame to add another column, which is the genres count, which is giving us how many genres that movie is classified into or tagged with. So now what we would want to do is plot and understand how genres are distributed. So to do that, I'm going to introduce the matplotlib package to you. which you can import, and we will access the pyplot part of it. So using the pyplot functionality, we can easily create a histogram of genres. So as most of you would know, a histogram is essentially a frequency map. It is telling us for each of the values in the data set when plotted on the x-axis, the y-axis tells you how many times does that element exist in the data set. So what we are going to do here is ask the plot object to create a histogram and pass it all the genre, basically this column. We are extracting this column from the data frame, the genre count column, and we are passing it to the histogram function. So now it knows what are the numbers it needs to work on. And then what we are telling it is to give it a title, X label and Y label. Let me run this and then this will make more sense. So once I run this, so this is the histogram that it has plotted. The first line is giving it the data, which is telling it what are all the unique, genre counts that exist. And, after that, we are telling it how to label the whole histogram with the genres histogram. We can set the X label, we can set the Y label. This is the X label, the number of genres, and the number of movies is the Y label. And we have also controlled the values, the range of values that are there on the X-axis and the Y-axis using the axis method. So we have set on the X-axis, use the range of 0 to 9, 0 to 9, and on the Y-axis, use the range of 0 to 5000. And after that, we have said plot it. So we have taken all this column from our data frame, passed it to the histogram function here, tell it how to, decorate the histogram, and then called the show method on it. So now this is the data that we have, this is the histogram that we have got. So what can we infer from this? As expected, we can infer that most of the movies have more than one genre or one or two genres. And there are very few movies which have 5, 6, or 7 genres as expected, right? So this is a way for you to use matplotlib and create a histogram of data, of your data. Right, let's move on. Now let's see how many movies are there for each genre. So we don't want to do a histogram of genres. Now we want to count how many movies are there for each genre, right? So now what we need to do is, for that, let's look at our data first. Okay, so this is our data. So we need to identify how many rows has adventure in it and plot that count against adventure. How many rows have animation in it and plot that against that. Again, this data is not in a very queryable format because we'll have to iteratively run queries to do this. So to do that, what we can do is essentially flatten this thing out. So if you access the movies data frame.genres array, which is this, right? It will give you an array containing these arrays inside it. But what we want to finally count is how many times adventure exists in each of those arrays. So what we're going to do is take this array of arrays and flatten it out into one big array, where we are collapsing the internal arrays, in a way removing those square brackets and coming up with one single big array. And that is done by this line of Python code. It is basically taking an array of arrays and creating one big list of a single array. And after that, we will use the counter functionality from the collections package on the flattened genres to create a dictionary, where the key would be the genre and the value would be the number of times it occurred in that flattened list. Let's actually print this out and see how it looks. Right. So this is how it looks. So we see that there are 543 mystery movies, there are 792 sci-fi movies, there are 1100 crime movies, and so on and so forth. Now let's actually plot this and see, can we gather some insights from that. So the way to plot this is I am going to choose a pie plot, which is a pie chart. So we are going to use the same plot object that we created here, the same plot object that we, here, and ask it to draw a pie chart where you have to give what is the size of each pie and how to label each pie. Those are the two parameters. So the size of each pie depends on the number of movies that are classified into it. So the values of our dictionary. And the labels is basically the keys of our dictionary, right? And then we give it a title and then we show it. So let's run that. And so using matplotlib, we have now, created this pie chart. So now let's see what it shows. So surprisingly, the genre with the most number of movies is drama. And there are also followed by comedy and followed by romantic movies and thriller movies. But yeah, so this is one way of visualizing this data, but we're not really coming to know how much, how is the distribution. So, what we can do is also try to plot a bar chart out of this data and see if we can find some more information there, right? So now we can use the same plot object and this time ask it to create a bar chart. But the problem here is all these functionalities take numbers as on the x-axis and numbers on the y-axis. What we have on the, here till now is this dictionary. This is what we have so far, where the keys are actually strings and the values are numbers. So for our x-axis, what I've done is created a range of 0 to the number of genres that exist in this data set. So let us say there are 15 genres all put together. So this will create a range 0 to 14, which will have 15 elements in it. And then what I'm doing is, using, let me actually plot this and then walk through this. That'll give a better idea. Okay. So let's look at this now. So this is what is the final plot that this code has created. Let's understand. So what we have said is, create a bar chart where the x-axis is this array. The values are from this array. And the y-axis, the corresponding values are in this array. Right? So the dictionary's values are the number of movies classified into the genre, so that is all good. But the x-axis, what you will have to pass is basically a range of numbers. So we have created a range of numbers which is equal to the length of the dictionary here. Then we have said on the x-axis, use these points, but don't display don't display that range. Instead, display the keys. And we have also asked it to rotate it so that it is more readable. So you can see the keys here are rotated. And also we can, do fancy stuff like, enable a grid so that it's easier to read. So now let's look at this data and see what we can find. Again, drama is the highest, followed by comedy. But there is one interesting thing here. If you see, there are more thriller movies than there are action movies. That's very strange. I would not have expected that. I would have expected action movies to be more. But in this data set, the number of thriller movies is actually more than the action movies. So sometimes, depending on the plot that you choose, maybe this plot is not that readable, this pie chart. But when you choose a bar chart, you get, you can maybe, get an understanding which is, so choosing the right plot to represent your data is also a very crucial step. Cool. So what have we learned so far? So just to summarize, so far we have learned how to work with CSV data using the pandas data frames functionality. Then we have seen how to, clean up our data and make it into actionable data by adding new columns, which are like we took the genres data, which was pipe separated. We created an genres array, which had the, was a data type array so that we could use and we could work with it more seamlessly. Then we learned, how to, use matplotlib to basically plot various pie charts, histograms, and bar charts. So that's what we've seen so far. Cool. So now let's move on to our second data set, which is the ratings these movies received. So what we're doing here is very similar. This is the path of that file on my file system. I'm just using the pandas read CSV functionality to create a ratings data frame. And let's see how that looks using the head function. Okay, so it looks like this. It says this user gave this movie this rating at this timestamp. Right. So now let's do some explorative analysis of this data. Let's see what we can find. So let's start with, let's see how many ratings do we have in this data set. So we can do that by measuring the length of the index like we did before, or the index property of the data frame. Next, let's find out how many unique movies have been rated. Have all the movies do we have in a data set? Do they have, all of them have ratings? How many of them have ratings? So we can do that by, taking the ratings data frame, accessing the movie ID column, and then doing a unique, which will give us the unique elements in it, and then doing the length of it, right? So it will give us the number of unique movies which have been rated in this data set. After that, how many different ratings have users given? Is the ratings on a scale from 1 to 10? Is it from a 1 to 5 rating? Is it a 3-star? What are the different rating values that exist? Very similar. We are going to the ratings data frame, looking at the rating column and doing a unique. So let's do this and see what the data looks like. Okay. So the number of ratings is about 1 lakh. The number of movies that have been rated is 9,066. And the rating values, as you can see, ranges all the way from 0.5 to 5. So it's essentially a 0.5 increments. You can give a 0.5 star, 1 star, 1.5 star, so on and so forth. Right? So now let us, find a little more stats. So this was some high-level stats. How many rows do we have? How many unique values are there in each of the columns? That's what we have done so far. Let's actually do a little more. Let's try to find what is the average rating across all the movies in this data set. So for that, I'm introducing the Numpy package, which is, the package we can use to extract various stats out of data. So now we can import Numpy and call it, give it a name NP for keeping it short. And we can easily find the mean, which is the average rating, by just saying numpy.mean ratings data frame dot rating. So we are essentially passing it all the values in this column, the rating column, this column, and asking it to give the mean. So let's see what's the, let's import it first, and now let's see what's the mean. Okay, so the average rating across all the movies is around 3.5. That's good to know. Now let us see what is the median rating. So as you guys would know, the median is essentially the center point of the array after sorting all the data. So once you sort your data, look at the midpoint, whatever value exists there, that is the median. It also reflects that 50% of your data has values less than equal to your median. So let's run this and see what that is. Okay. So we see that our median is 4.0. So the median rating that movies have got is 4.0. Right? It tells us that 50% of the data here has got a rating of 4. Right? So what that means is people come and rate when they actually like stuff, right? So only 4 and 5 stars is what, 50% of the data is 4, 4.5 and 5. Right? Similarly, let us now find what is the percentile. Many times, you would like to find different percentiles of the data. So what we're trying to find is what is the 30th percentile rating, which says that, how many, what is the rating that 30% of the movies have got below. So once we do that, you see that 30% of the movies here have got a rating of 3.0 or below. That's good. So there are people who have come, this data is varied. So you have ratings across the board. Cool. So now also let's try to find, what is the most common rating users have given. So the most common element in your data is called the mode of the data. So let's try to find that. So to do that, we will use the scipy package and use the stats module in that. And we can do stats.mode of your entire rating data. So we have just passed it the rating data just like we are passing here. And once you do that, we can run that. You see that the most common rating given is 4. And 28,750 of the 1 lakh ratings we have is actually a 4-star rating. That again tells us that people come and rate when they actually like stuff, like they want to appreciate, the movie. Cool. So now, let me do a quick time check. Second. Okay. Cool. So now let's, plot a histogram which tells us for each of the ratings, how many movies have got that rating. So very similar. We are essentially asking using the plot, we are asking it to draw a histogram and passing it all the ratings. But now that we know what are the values that exist, we can give it what ticks to put on the x-axis. We know that the ratings can only have these values. So we pass them in and we, label the x-axis as ratings, the y-axis number of movies. So once we run this, we see that most of the movies, as we have already found, have a 4-star rating, followed by a 3-star rating, followed by a 5-star rating. So people come and rate when they, like stuff. So 4-star and 5-star. The other thing to notice here is there is a huge difference between the 4-star rating, the 4.5-star rating, and the 5-star rating. Similarly, the 3.5-star rating is way smaller than the 3.0 rating and the 4.0 rating. Again, the 2.5-star rating is, less than the 2 rating and the 3 rating. And this is a trend across. 1.5 is less than 1 and 2. Essentially what it tells us is maybe people do not think in terms of 0.5 ratings, either give a 3-star or a 4-star. It also tells us maybe the interface that we have to collect 0.5 rating, the increment 0.5 is not very usable. So people try to give it and the whole thing gets selected, the 4-star gets selected and they give a 4-star rating. So when you visualize data like this, it is easier for you to find these things. Because I would have expected that if 4-star is so high and 5-star is 4.5 also would be more. But that's not the case. So all the 0.5 ratings are like sandwiched between the 2 integer values around it, as you can see there. Right? All right. Cool. So now let's move on and try to find the highest rated movies in this data set across all the movies which are the highest rated. Let's have a look at our data. This is how it looks. What we're going to do here essentially is pick just the movie ID and the rating column, which is what we're interested in, and then do a group by the movie ID and find the average rating and then sort it by the rating column in the descending way and the top 10. So this should give us the highest average rated movies in this data set. All right. So these are the movies, but where are the names? We don't have the names. We don't know which movies these are. To do that, what we have to do is join both our data sets to create one consolidated merged data frame, which has the name along with the rating. It is very similar to a SQL join kind of operation. So to do that, all you need to do is you have to ask pandas to merge the ratings data frame with the movies data frame on the movie ID column, and then we can create a merged or a joined data frame. Let's run this, and this is how that looks. So now for each of this, we also have, the genres and the title. So when we rerun our thing now, we should see the top rated movies. Okay, so these are the top rated movies. But where is Shawshank Redemption? How can there be a top 10 of movies without Shawshank Redemption, without Pulp Fiction, without, maybe even Sholay? I don't know. So there's something wrong. Let's try to figure out what's wrong. These are not the movies that are top rated. Definitely not. And this being real data, it should give us the top movies that we expect, right? And none of this, I have not seen any of these actually. Maybe some of you have, but I haven't. So let's see. So there is something wrong here. And one way to verify is how many ratings have these movies got. Maybe all of them have just 1 rating and it's a 5-star rating, so it's showing up. Let's see. So the way to do that is you can take the merged data frame and from that we will just try to see how many ratings this movie has got. This is the first movie here. That is the idea I have put here. Okay. So when we run this, yes, it has only 1 rating, and that is why, and it is a 5-star rating. That's why it's figuring here. So essentially what we need to change is we have to consider movies which have got at least 100 ratings. So this is another thing that I wanted to bring up. When you analyze data and look at results, you should be able to intuitively connect those results back to the data. That's why understanding of the data is critical. The reason we are able to relate to this data is because it's movies that we have all seen, and we were able to catch that these are not the top 10 movies. Right? So now what we're going to do is only consider movies which have at least 100 ratings and then see what the top 10 looks like. So that's what I'm doing here. I'm basically taking the titles data frame that we created, and I'm trying to find all those movies which have at least more than 100 ratings. Let's see, and I'm calling that data frame as well-rated movies data frame. So this is a new data frame I'm creating, which only has those movies which have more than 100 ratings. So when we run that, okay, so these are the movies that have more than 100 ratings, the first 5 that we have found. So now what we need to do is, take our joined data frame where we join both our data sets and filter it to only consider movies from this well-rated set. So that is what this line of code does, where it takes the merged data frame, the joined data frame, and it only returns those rows where the movie ID is in the well-rated movie ID list. That's what this line does. And after that, we are running the same code as above. We are basically, grouping by the movie ID, finding the mean, sorting it in this descending way, and finding the top 20 movies. So now let's see how that looks. It's taking a little bit of time, crunching through 1 lakh movies. And here we go. All right. So these look much better. This looks like a top 20 list that we should all have. So it has all the usual suspects in that. Great. So the lesson here is when you look at data and you try to understand it, one important thing is when you look at the results, you should be able to intuitively connect it back to the data. Otherwise, maybe the insight that you have or the data that you've extracted is incorrect. Let's move on. Great. So what have we done so far? So far, we have extracted various stats from our data set using the Numpy, pandas packages. We have visualized it using the matplotlib package. Now let's do some predictive analysis. So what is the predictive analysis we want to do? What we want to do is see how the number of ratings in this data set has varied over the years and try to build a machine learning model which will predict how many movies we can expect going forward in maybe 2019 and 20 or 2025. To do that, first we need to come up with how many ratings we have had on every year. So again, what we need to do is take our data, which looks something like this, and basically populate, not this one, yeah, this one, and populate a column which says which year was this movie rated for each rating. So to do that, we go back here. We essentially use the date time format. We pass the Unix timestamp and extract the year from it, and add a new column called rating year to it. Let's do that. Cool. So now our merged data set also has a new column called which year was the rating given. Now what we need to do is essentially, just group by the rating year and, count how many ratings we have got. Let's do that. So this is the result. 1995 only 3 ratings, 96 so on and so forth. 1999 5,900 ratings, so on and so forth. Now let's actually plot this data and see if we can see a trend in it. So now the way to do a plot, till now we have seen the histogram plot, the pie chart and the bar chart. Now we are looking at a scatter plot. A scatter plot is just throwing all your data on a 2D array. The different points scattered all along based on the values of x and y. So the x-axis is obviously the years, the y-axis is the number of ratings. So let's plot this out and see how it looks. Cool. So this is how the number of ratings in this data set has varied over the years. So in the year 2000, it has had about 15,000 ratings. In 2015, it has had about 7,000 ratings and so on and so forth. So the way predictive modeling works is we look at all this data and we try to fit a curve to it. Some curve along that fits the data. And using that curve, we try to predict values within this range and outside this range for years to come. So the curve that you choose could be a linear, could be a straight line with a y equal to mx plus c formula, or it could be a polynomial. So the first regression model we'll build is trying to fit a straight line to this data and see if that is a good enough model to predict data in the future. Okay. So now I want to show you how simple it is to actually build a linear regression model of your data using the SciPy package stats module. All you need to do is call stats.linearRegress x-axis and y-axis. And it will return you back a straight line which is most optimal according to it that it could find. It will give you the slope and the y-intercept. So let's run this and see what kind of straight line has it given. Okay. So it has run, it has populated all these variables for us, and the straight line is y equal to minus 25 into x plus 54,200. So this is the linear regression model that is built, which is the best. Now let's use the slope variable and the intercept that we got to create a function which will now predict. So I've taken the slope variable and the intercept and created a function called predict number of ratings given a year, which returns slope into the year plus the intercept, y equal to mx plus c. And I have passed it all the years that we have, all the values on the x-axis, and whatever the predicted values it has given, I have captured it in the predicted ratings object here. Let me just print that to show you. Okay. So every year, this is the predicted ratings according to this model. Now, how do we see, how does it look? So let's plot the real scattered data, the real data, and let's plot the values predicted by this model on the same plot and see how it looks. So we are doing plot.scatter, the real data, and plot.plot, the actual predicted ratings that we have calculated, and see how it looks. So when we run this, so this is the data that we have, the blue dots, and this is the linear regression, the linear model. That's the value it's predicted, right? So whenever you create a model, you need to figure out, how good the model is, how well is it fitting, how many points are close to it, are, and that tells you the accuracy of the model. So to do that, it also, when you call the linear regress function here, it returns you something called the R value. And, if you take the R value and square it, you get something called Rsquared, which is a value which will range from 0 to 1. And the closer it is to 1, the better the model that you have. So if you have two functions, one like this, and let us say another like this, how do you know which one is matching all our data? Here we have only a few points, but you might have a million points in reality. How do we know, which one it is matching there, right? So the way to do that is, when you do the linear regression, the package, the library itself is telling you what is the actual linear function using the slope and intercept. It's also telling you what is the, in a way, a measure of the accuracy of the model based on the data that you passed it. You passed it the x-axis and the y-axis. So it gives you back an R value. So once you square that and see, let us see. If it's closer to 1, it's a good fit. If it is closer to 0, it's a bad fit. So let's do that. And what do we expect? Just looking at this data, what do we expect? Just take a second. Do we expect it to be closer to 0 or 1? Let's see. All right, it's nearly tending to 0. So this is a very, very poor model for our data. So essentially, we just took one algorithm out of the box. We said, okay, let's try linear regression and see if it fits our data. And the R-squared value that we calculated is nearly 0. So it's essentially a very, very poor model. So obviously, a linear model is not a good choice for it. And that was evident just looking at this data. It's very hard to fit a line that will be close to most of these points, right? They look all over the place. So what else can we do? Let us try a polynomial. So polynomial, can dance around like this maybe, and fit to more points. And again, this is called polynomial regression. So till now we did a linear regression. We found our linear model. We calculated its, R-squared and found it to be nearly 0, which is a poor model. Let's see if we can do better with a polynomial model. So the way to do a polynomial model is again very simple. All you need to do is called numpy.polyfit, pass it the x-axis, the y-axis, and the degree of the polynomial that you want. So this is the only parameter that you can play around with. So I have chosen third degree. If I choose a 1 degree, degree 1, that will be the same linear model as above. I've chosen a degree 3. Let's see how it works. And then I'm, getting back a function which is basically similar to our predict number of ratings function. So this is a function which will take in the year, but its formula won't be a linear formula. It will be a polynomial thing, and that's what it returns. So we took the x-axis, we passed to the polyfit function the x-axis, the years, the y-axis, the actual values, and we asked it to create a third degree polynomial with the best match it can. And then we are just plotting it against our data to see how it looks. Okay, interesting. So our polynomial is actually, moving around, it's turning and twisting, trying to match the data. So now again, how do we measure how good of a fit this is? The same thing, we, have to calculate the R-squared. And to do that, the linear regression model gives you the R value directly. In this case, you have to essentially call the R-squared score, pass it the actual values and the predicted values, which basically our polynomial function is giving. And it will give back the R-squared value. Let's see if this is any better. Okay, so this is slightly better. This is actually way better than the previous one, but it's still, not close to 1. So what did we do? So we basically, tried the linear regression. We found it to be having a very, very poor R-squared value. Then we moved on and we tried a polynomial regression with, a third degree polynomial, and we calculated its R-squared. It's better. So definitely this polynomial regression, it's better than the linear regression model for this data set. So that is why it is important to first visualize your data and see if, straight line makes sense. Here it clearly didn't make sense, but we still tried it out and figured out a quantitative way to measure how good a fit this model is, which is using the R-squared value. Then we tried out a polynomial function. We can go crazy here. We can actually, try polynomials of different degrees. Let's try a 5th degree, 4th degree polynomial and see if our R-squared value increases. Okay, so this is the 4th degree polynomial. So currently our R-squared value is 0.276. Let's see if it increases. No, It is nearly the same. Let's try maybe 5th degree. So yeah, so you can essentially, be able to play around with your data and, see. Yeah, so the R-squared value slightly increased. But that's the point. You don't want to ever go into a case where your curve is dancing around just to fit the data. So it should be generally, it should be less than 7 or 8 degree polynomial. So yeah, so I still like my 3rd degree polynomial and I would stick with it. So rerun this. Okay, so now that we have done this regression, what can we do? We started out with the aim to predict how many ratings we'll get in the years to come. So now that we have our polynomial function, which is a better model than the linear function, let's use that to predict how many ratings we will get in the year 2017 and 2018. That is as simple as calling that function with whatever year you pass it in. All right. So once we run this, okay, so according to this model, we should expect 8,203 ratings in the year 2017 and about 10,500 ratings in the year 2018. Cool. So what have we done in the machine learning part? So we started out with, calculating the data that we want to build a predictive model on, which was the number of ratings year after year. We scatter plotted that we scatter plotted it, and then we tried a linear regression model first. And to do that, we used the linear regress function from the stats package of SciPy, which directly gave us the slope, the intercept, and the R value. All we needed to do then is, take and create a function based on the slope and the intercept, which can predict the number of ratings given a year. Once we did that, we were able to, actually pass all our years and see what this function returns. Those are the predicted number of ratings. Then we plotted that on top of our real data to create a plot like this. And then to see how good of a model it is, we calculated the R-squared value and saw that it was nearly tending to 0. So that is basically a poor model. Then we tried a polynomial regression and we could find a fit like this, which was a slightly better model because its R-squared value is better than the previous one. Cool. So this is the regression, the linear and the polynomial regression you can do with the scikit-learn module. What else can you do? So you can do cluster analysis. So you can take basically movies and cluster them into buckets, like similar movies, based on the ratings people have given it. You could build recommendation systems. You could do customer segmentation. You could put similar customers together. So that is cluster analysis. That is also like this 3 or 4 lines of Python code, and you'll get your cluster using the scikit-learn package. We can also do classification of data. So classification is taking data and categorizing into predefined buckets. For example, a spam filter, which takes an email and classifies it as a spam or a not spam, or an image recognition, model, which takes an image and maybe classifies it as adult content or not, or whether it's an image of a hotel or of an image of the ocean or things like that. So all of this and much more is possible with the scikit-learn package. Right. So we're right on time, and this is all the stuff that I wanted to cover. So let me now go and see if you have any questions. Yeah, so there is a question from Sujit. He's asking that, so all of this can be done in Python only and doesn't need big data tools? Yeah, so essentially whatever we have done so far, we have just used plain Python and Python modules. We have not used any big data technology like Hadoop or Spark. But the choice depends really on the size of the data. If you have a trillion movie ratings, or if you have a lot of movies, or if you have to do real-time analysis of movies. So based on the use case, based on the volume, or based on the velocity at which the data is changing, you might not be able to use these techniques, and you will have to go for a big data stack. But yeah, all of this can be done using pure Python. We haven't used Spark or Hadoop or MapReduce or any of that. But what I'd like to point out is all that we did here, we could also do with Spark. So Spark is a big data technology where where here we add a data frame object. Remember, so Spark has a RDD data structure on which you can do very similar operations that we were doing on the pandas data frame. So you can transform an RDD into from one to another. You can pass map functions to it, run reduce functions on it. Essentially, the stuff we did here on the pandas object, you can do on a Spark RDD object. Right. All right. So Ulfa Nadia is asking, yes, so the code that I have here, he's asking whether I can access all this code. And in the presentation I showed that I have my public GitHub repo, which I will paste on the chat here, and you guys can all clone the code from there. So all the code is available here, and the data set is available here. So you can access this at any time and play around with it. Yeah, so Mukul Taneja is asking a question. How can one decide which model will work better in the given data? Yeah, so basically the way to decide that is to first have a good understanding of the data. Like we did, we actually scatter plotted the data and then we said, would a linear regression model work well or would a polynomial model work well? It really depends on how the data is distributed. And what I want to impress on you is building a model and testing out how its accuracy is not some rocket science. It is literally 2 lines of code in Python. So once you do that and calculate the R-squared value, you can try various models and see which fits your data best. Because only your data can tell you which model is best suited for it. So the aim is to try multiple models, see how each of them performs using a test train cycle. So the way normally people do this is, let us say you have 1 million data points, right? So they will build the model using the 700,000 data points and use that model to predict the remaining 300,000 data points and see how well it predicted. Because for those data points, we have the answer. We already know what the value is. So we can use a train test method on using all these models and see which one is giving the best results. Another important thing to keep in mind here is maybe given your data today, you might a third degree polynomial might be working out very well. But given future data that is coming up, you might have to revise your models. You might have to rerun your train test and see, if right now maybe a quadratic or a fourth degree or fifth degree function is better. So just like, maintaining a product where you keep adding features and things like that to building a product, the same way you have to, keep enriching and keep redefining and keep, evolving your machine learning models. And these models that we created, by the way, the linear regression model that we created, we can actually use Python's pickle functionality to serialize it and save it in a file. So you train your model, build it, save it to a file, come back a week later, read the model from the file into an in-memory data structure and continue predicting. Cool. Okay, so the next question, Sujit Kumar is asking, what may be the limit of the data set where we can start using big data? Yeah, so what I would suggest to all of you is, if there is a data set that you're able to bring to your laptop, open and look through, then you don't need big data. All you need is all the packages we spoke about. But if there is a data set which will take you 5 days to download, or if there is a data set which is, changing all the time, it is essentially you need to have it, on the cloud somewhere. If there is a data set, which you cannot process with a single machine, because it has so much data in it. If you observe the presentation where we were trying to calculate the top 20 all-time movies, it actually took some time to give that result, even though there were only 1 lakh ratings. So there will be cases when you can start, doing your analysis. At some point, run some functions which are so costly that it takes hours or minutes for you to get the data answer. then you can again consider, big data technologies. So there is no magic number like 50 GB or 1 trillion rows or anything like that. 1 trillion rows also can be easily processed if they are, of a certain kind. So the main takeaway is if you're able to get data to your laptop, then you don't need big data. If you're able to get your data to your laptop, open it, then you can use all these technologies to work with it. But if the data set is so big and the data set that it will take you days to download, or if the data set that you have has so many properties that it is split across 50, 60 files. Our data here was split across 2 files. One was the movies catalog and one was the ratings catalog. But let us say there are like 50, 60, 100 different attributes and there are like millions and trillions of rows. Then getting all the data on your local machine and using just the machine, the CPU and the memory that you have on your local machine does not make sense. You want quick results and you want to go through a lot of data, then you should use a big data stack. And as I said before, everything we did here can all be done in Spark, using, again, Python as a programming language. So Spark is a big data technology which gives a Python interface as well, which is called PySpark. And it's the methods and the APIs that it has is very similar to what we saw today. Okay. Let's see. Yeah. So Harshpal has a question that I would appreciate if you could discuss something about related to the probability functions, like what is the probability that next year's movies would get better ratings than previous year. Yeah, that's a different analysis altogether. And there, we would have to use different techniques. We will not be able to do it with the linear and the polynomial regression that we did. And I think that is a topic for its own webinar. So yeah. So do feel free to reach out to me on my GitHub handle that I've shared. Let me put it out here again for all of you. You can reach out to me on GitHub and we can discuss further. Yeah, so question from Karthik R. Please quote us an example where you applied data analytics in Flipkart. Were you able to match it against the prediction? Yeah, that's a great question. So I'll give you an example. So one of the types of fraud that happens in any e-commerce company is called a reseller fraud. A reseller fraud. What that means is one seller acting as a buyer, ordering all the items from a competitive seller so that his items go out of stock and the competition's items go out of stock for a particular product. And the guy doing the fraud, his products become the preferred product on the Flipkart page. So this was basically a reseller fraud. So where we used to, the main problem was looking at users who might be using different accounts as a seller or as a buyer. We had to detect reseller fraud. That is one example. The other example is, we get Flipkart has a lot of products, like crores and crores of products that are there on the website. Most of them are out of stock, but they still have a catalog. They still have data, describing the product. What we had to do initially, team used to sit and review every product's catalog. They will review, okay, what is the title of this product? Is the weight correctly entered? Is the dimensions correctly entered? Is the battery life correctly entered? Somebody would sit and verify that looking at the physical product. But as the number of products grew, what we had is we could not just, verify the catalog of every product that we were selling. And what we had to do is build a machine learning model which will predict which products need to be QC'd and which do not need to be QC'd. So that was another example of big data analytics where we had to use historic data of where the catalog came from, which categories have a higher likelihood of the catalog being incorrect and hence need QC. Like there were, I don't remember, there were like 5 or 6 other parameters. All of that was included in building a model through which you pass a product and its catalog, a new product and its catalog, and it will tell you whether you need to review the catalog before putting it out to the users. Okay. Okay, so I have another question from Mukul Taneja, who is asking how much math, according to you, one should be good at to get perfection in machine learning. To tell you the truth, I'm myself not a perfect in machine learning. It's not like, I'm an expert in this field, but what the little bit I can tell you is, it is not about knowing the entire math. It is about having an idea about how it works. I myself do not know, for example, how the linear regression function internally chooses which is the best straight line given our data points. I do not know. That is, to me, internals of that algorithm, and I trust the library to give me the best linear function. But what I will apply my brains to is whether I should use a linear model or a polynomial model, right? Looking at the data set. So according to me, the math that you need to know is not that much. It's not like you have to be a probability or a stats guru. You basically have to start digging in, looking at data, treating data like you would treat code. You guys are all here on Hackerearth, so I'm assuming you all are interested in coding. So the way you look at your code, right? That's how you should look at your data as well. You should structure your data. You should write comments in your data. You should understand your data. Like you have unit tests for data for code. You should have unit understanding of your data, right? So basically, I do not think like you need to be a math expert at all. All the terminology that exists around, stats and all of that are all like linear regression. The name is seems like some very complicated thing, but it's essentially fitting a straight line to match your data, right? So yeah, so it's not like you need a lot of math or you need to be an expert at math to be able to do all of this. Okay. Yeah. So Abhijit has a question for me. He's saying, how can I read server logs, either database or Linux, look at warnings and predict the next machine failure or next peak on the machine? Okay, that's a great question. And I think this is a solution that already exists. So there is a software called Logstash, which is, I'll just type it out here. You should definitely check it out from the Elastic Stack. So this tool essentially does what you're talking about. It gathers logs from across hundreds of machines where your software is deployed, and it tries to go through them, and it knows if it's an Apache log, it knows what is an internal server error and which line is a normally processed request. It knows, it can look at the access logs and figure out when your usage peaks. And the parameters there obviously are the model that you'll have to build to be able to predict such things should look at at what times do the loads, what is the load at any given point in time, when has historically errors happened, maybe there are external factors like whenever new code is deployed, that after that there is a higher likelihood of new version of the software is released, there's higher likelihood of errors increasing. So you might have to bring in that data also into your data set, not just the log. You should also be able to parse the log and figure out when was the deployment done, right? And then there could be more reasons. When a code written by a certain person gets deployed, there's a higher likelihood of failures and errors. That could be a thing. Then you'll have to go read the Git logs, who all committed in this patch that we are releasing. It could be that when we deploy on machines without solid state drive SSDs, then errors increase or latency increases. So basically, this is the part of machine learning that is domain specific. You will have to understand your domain of errors and increased latency, and figure out what are the parameters that affect these things, and then build a model which uses all those parameters. First, get all that data. Getting all the data is the hardest part, let me tell you already. Even in this example, we are talking about how do you get who all committed code. You'll have to integrate with some version control system to figure out in this patch that I'm about to deploy, who all committed code in this. Maybe the number of lines that have changed matters. Maybe it matters at what time of the day we deploy, or what time of the day. The time of the day. Obviously, the traffic depends on the time of the day, given the type of your business. Are your clients in the US area, or are they Indians in the Indian time zone? It depends on that. So basically, there is a domain angle to data, where you will have to think about the problem like a product manager would think about designing a product. You'll have to think about what are all the aspects which can affect the outcome that I'm trying to predict, and then gather all that data and just pass that into your training, your model building. And the algorithm will take care of, building the model. And then you have to use that to test whether, okay, if I use 70% of my data and train it, is it able to predict well in the 30% of, the remaining 30% of the data. Cool. Okay. So there's a question from Harshpal, who is asking, for beginners like me, which OS platform and software, etc., we should use, any recommendations? So I would, so if you're beginning out, to enter the machine learning or, data science or data analytics domain, I would definitely recommend you to, have, as an operating system, you could choose, either Linux or Mac. Those are the operating systems I in general prefer. Windows, especially because of, I won't recommend Windows because of all the bad things that happen and that have happened recently as well. So I would recommend always being on a solid operating system, because Python and all the languages, Java. So most of the big data analytics is done using Python, Java, and all of these languages are platform agnostic, so they can run equally well on Mac or Linux or anywhere. So I would recommend a Mac or a Linux or an Ubuntu-based system. And in terms of software, I would recommend you to have a good look at Python and R. Because most of the data science and data scientists around the world are slowly moving, are primarily using Python and R. So those are the two languages that you should pick up. Okay, so any other questions, guys? All right, thank you so much. It was very nice discussing with you, and I hope I have been able to impress on you how easy it is to get started with data analytics and visualization using pure Python and its awesome libraries. Thank you for your time. Nice talking to you.